And this is part 2 of the lecture on aquatic biodiversity. And here we will be skipping to section 4 of the book and focusing on the freshwater ecosystems. This section tends to have the most problematic vocabulary for students, so please pay attention to the words, try to think of ways to remember them and differentiate them, because this will trip you up on the test. Okay, so why are freshwater ecosystems important? We've already said why oceans are important, but again, we've got that same idea of ecological and economic services. They're reservoirs of biodiversity, but even more than that, we need water, and that is becoming more and more apparent. So how do we divide up our freshwater systems? I mentioned before that it was going to have to do with the flow of the water. And so we divide them up into standing bodies of water, these are lentic systems, and flowing water, and that is a lotic system. So this only applies to fresh water. Lentic, standing, lotic, flowing. The way that I tend to remember this is flow, low. You've got that same LO in the words. Standing, you're just going to have to remember that it's standing. So standing water, lakes, ponds, and inland wetlands. Again, those lakes and ponds, we're going to be differentiating them based on size, and that's really going to be the only factor. You guys will not have to know the differentiation between a lake and a pond. Just know that lakes are bigger than ponds. Same thing as a mountain being bigger than a hill. There is a distinction, but not even everybody uses the terms correctly. And that's okay for our purposes. If you want to be a geologist or if you want to be a limnetic biologist, then you will have to know the difference. And then again, the inland wetlands, those are the areas like marshes and swamps. It could be prairie potholes. There are a lot of different types of inland wetlands. We even have a couple of them right around the school. If you think about the areas where the runoff water tends to accumulate, they are fenced off areas, and they've got basically a little basin, and that can hold water during periods of very high rain. That would be considered an inland wetland. We also have a fairly large wetland between Brookwood High School and Brookwood Elementary School, covered with lots of algae and ickiness, but I would consider that area to be a wetland as well. Okay, and then you've got your flowing water, and this is again lotic, streams, rivers. We do have some differentiations there based on size, based on flow, but even something like stream order and figuring out the size and flow rate of a river is something that we don't do in this class. There are ways to calculate it, but we don't have to worry about those, not even for any of our mathematical FRQs. Okay, so again, this is going to give us ecological and economic services. Your book does a great job laying these things out. So I'm not going to read through them all, but I think some of the ones that we've talked about before are waste treatment, flood control, groundwater recharge. Those sort of in the center there are incredibly important ecological services. And some of our case studies are going to bring those up as well. As far as our economics, food, recreation, water, I personally think that we should put the water more under ecological services because it's going to purify our water for us. But again, we can make money off of water, and so it makes sense as an economic service as well. And also there we've got transportation corridors. The Mississippi is still a huge shipping channel. There are still large boats that go up and down the Mississippi. Hydroelectricity, tons of reasons to care about freshwater ecosystems. Okay, so standing water. These are another set of vocabulary terms that are very problematic. So standing water, this is again lentic. Standing water is lentic. And there's 3 ways that lakes can be formed. This, I hope, is a little bit, at least this first one, I hope, is review from Earth systems back in middle school. But lakes can be formed by glacial action. As glaciers retreat or as they advance, they carve out the land down to the bare bones, because think about how heavy a glacier must be, especially if it's 30, 40 feet thick and it's just solid packed ice. So as it moves, it's going to take everything that is soft or at all pliable, it will take it away. And so we do get a lot of lakes. This is why the northern states have far more lakes. You've even got, oh, it's one of the M states again, and I'm going to forget it, but I think Michigan is the land of 10,000 lakes. They've got their Great Lakes, but then they've got plenty more lakes everywhere. Crustal displacement is another way that we can form lakes. So if we think about what would happen if we had a divergent plate boundary over land. Remember, we get an oceanic ridge if the crust moves apart in the ocean. But if it moves apart on land, then you get a legitimate rift valley. And you can fill that up with water and it would become a lake. Also, volcanic activity can cause craters, and those craters would fill with water, becoming lakes. And this is what Crater Lake is. And again, I'm forgetting my geography. It is up in the northwest. I'm wanting to say Oregon, possibly Washington, but it's a very famous lake if you've not heard of it before. Very pretty, crystal clear blue water. Okay, so when we've got a lake, we need to know what area of the lake is responsible for the productivity and what part of the lake is more responsible for things like the fish. So we break it up into 4 zones based on depth and distance from shore. So the 4 zones are littoral, limnetic, profundal, and benthic. Benthic is the easiest one, so let's go ahead and throw that right out there. Benthic always means bottom. We had benthos already. Now we've got benthic. You're going to have a benthic in the ocean as well. So those are going to be easy, or at least easier than littoral and limnetic. So now we go to the picture that's going to show you what you can label in your diagram on your notes page. And so again, we said benthic is the bottom. I want to go over here to the littoral zone. The littoral zone is the area near the shore where you have plants, submerged vegetation, floating vegetation, any type of plant matter is going to be in the littoral zone. The limnetic zone is also classified as just the top area of the water. You would have photosynthesis out here. That's going to happen with phytoplankton. You see plankton here. These would be some phytoplankton, green. Obviously, a zooplankton, maybe a water daphnia. But the plankton are going to be out in the middle of the limnetic zone. And again, those phytoplankton are going to have to rely on the sunlight. So you do have productivity going on in both places, the littoral and the limnetic. Another way, I don't know if this will help you guys remember it or not, but limnology is the study of a lake. So the limnetic zone sort of makes sense. It's just the top of your lake. The profundal zone is going to be just below the limnetic zone and the benthic zone. We've got a big breakdown here based on sunlight penetration. You don't have enough light to have any kind of photosynthesis going on in the profundal zone, but you're also not on the bottom. The good thing about being on the bottom is that that's where the nutrients are going to collect. They're going to come in through the shoreline, and you've got plants there to soak those up, and then they're going to end up falling down to the bottommost area. And then this animation is going to go through some more of those ideas of lake zonation. Here we see again the littoral zone. The littoral zone extends around the lake's edge from shore to the depth where aquatic plants stop growing. Limnetic is the lake's open, sunlit waters. Again, so we've got light in both littoral and limnetic, but littoral, again, the idea of those plants is most important. And the profundal zone, all water below the depth of light penetration. Now, is there a benthic zone here? Of course there is. It is the bottom. Benthic really just means the bottom. It can best be applied to the substrate, the bottommost silt, sand, sediment. And so we'll see that again in the ocean, how we'll talk about benthic, and we might not be at the very, very bottom of the ocean, but we are touching the ground in the ocean. And so we'll look at that in a second as well. one of the things that occurs in a lake, just like occurs out in the ocean, is called lake turnover. Now, in the ocean, this is the same idea as our upwellings. But where we had upwellings before, we knew that that had to do with winds and currents pushing water aside and the cold, nutrient-rich water coming up to the surface. Well, we have the same issue going on in lakes where the cold, nutrient-rich water wants to stay down at the bottom. This animation will help, hopefully, to make some sense out of the idea of lake turnover. And so what we see here tells us this is the winter profile of a temperate lake. That would be like what we have in Georgia. Ice would cover the lake, and water near the freezing point is the least dense and accumulates beneath the ice. So if we look at the depth in meters, this would be a 0 degrees ice sheet at the top. And then right below the ice, we've got our coldest water. Water at 4 degrees Celsius is densest, and so it will be in the deeper waters. Again, that deeper water is going to be where the nutrients are. And so if we go again, this is going to be summer. In summer, the lake has a thermocline. Thermocline is this area right here on the graph. Okay, thermocline, mid-layer of water where the temperature abruptly changes and blocks vertical mixing. Being warmer and less dense, the surface water floats on the thermocline. Decomposers may deplete water of dissolved oxygen. So this is a very bad thing, but it happens a lot of times in the summer months where that warm water cannot mix with the nutrient-rich cool water. And so we've got a lot of producers up here. They're using up a lot of oxygen, and we end up getting what we call a fish kill. Now, on that same topic of nutrients, some lakes are going to have more nutrients than others. And some of that is naturally because of what feeds them, what types of streams and rivers are coming in. And some of it can be made worse by human activity. And so our three types of lakes are oligotrophic, eutrophic, and mesotrophic. First thing I want you guys hopefully to just pick up on is you see that trophic again. We talked about trophic levels in this unit. We talked about that was your feeding level. So troph having to do with nourishment and feeding. An oligotrophic lake has low levels of nutrients. So that means low photosynthesis. Remember, NPP, net primary productivity, is photosynthesis. So low photosynthesis going on in oligotrophic lakes. Eutrophic lakes, hopefully you remember that EU from back in biology. We talked about eubacteria were the true bacteria. These are truly nourished lakes or well-nourished lakes. Lots of nutrients in them, lots of NPP, so lots of photosynthesis. That means the food chain is going to be very supported and everybody is going to be happy biodiversity-wise. Mesotrophic lake, meso, middle, it's something in between. And we're going to look at pictures in a minute. And oligotrophic and eutrophic, they're good for different things. Mesotrophic, middle ground, if you wanted to say, mesotrophic is great because it's halfway in between. But I'm going to show you some pictures and you're going to see what they're good for, these different types of lakes. If we add too many nutrients through fertilizer runoff or through phosphates in our dish detergents running into our sewer lines and not getting treated, then we get cultural eutrophication. We're adding too many extra nutrients, and that's a problem for a different reason. So here's two lakes, and yes, that is a lake on the right. That is not a big meadow. It is a swampy, algae-covered lake. But the one on the left, this is Crater Lake that we were talking about before. Crystal clear blue waters, poorly nourished. You would not want to fish in there. You would want to fish, however, in the lake on the right because the food chain is going to be very, very supported. And so that's the difference between a poorly nourished and a well-nourished lake. Now, this is your homework assignment. You have the directions on another piece of paper, on your note paper, but you need to find out about cultural eutrophication and how humans impact a lake. It gives you all the steps right here. And then these are your captions. You need to have pictures. You need to have these in order. It's basically making a cartoon strip out of cultural eutrophication. And that's the end of lecture part 2.